Okay, testing two populations standard deviation. For this, we need to have some criteria and some information. Our null hypothesis will be sigma 1 and sigma 2 being equal, and our alternative hypothesis will be that they're not equal. So this process will always be a two-tailed test. For the critical value, we're going to use F distribution and program fval to find the critical values fr and fl. We talked about degrees of freedom in the last presentation on F distribution critical value. We also need to find computed test statistic F and p-value P. And for that, we're going to use 2SampFTest programmed by TI. And at the end, we're going to make a conclusion. The conclusion will be that if HO is valid, we assume the two population standard deviations are equal. And if H1 is valid, then we assume that the two population standard deviations are different. Let's look at an example. Before we look at the example, we always have to make sure that our sample 1, which we refer to it as the numerator, has a standard deviation greater than sample 2, which we refer to it as the denominator. So once again, sample 1 standard deviation, S1, has to be greater than sample 2 standard deviation, S2. Sample 1 will be our numerator, and sample 2 will be considered as denominator. So now let's take a look at an example. We're comparing two standard deviations, one from campus bookstore and one from off-campus bookstore. So looking at the standard deviation of each, we notice that off-campus bookstore has a larger standard deviation of 8.75 versus the campus bookstore, which has a standard deviation of 6.85. So our sample 1 will be the off-campus bookstore. N1 will be 8 and S1 will be 8.75 and X1 bar will be 70.85. And the same way, S2 will be 6.85, N2 will be 12, and X2 bar will be 7250. So once the information is given to us, we need to take a look at the standard deviations and see which group has a larger standard deviation. That group becomes sample 1. And the other group becomes our sample 2. So our HO will be that two population standard deviations are equal, sigma 1 equal to sigma 2. And our alternative hypothesis would be that sigma 1 is not equal to sigma 2. Once again, this would be a two-tailed test. Now, if alpha is not given, the significance level, we're always going to use 0.05. And this is going to be a two-tailed test. So the right tail critical region is 0.025, and a left tail critical region will be 0.025. Now, we use the program fval to find fr and fl. So the numerator degrees of freedom will be 7, and the denominator degrees of freedom will be 11, and the right critical value will be 3.759, always 3 decimal places. Now to find FL, we switch the degrees of freedom. So now the numerator degrees of freedom is 11, and the denominator degrees of freedom would be 8. We use the program fval. Once we get the answer, we take the reciprocal of that answer. In this case, becomes 0.212. Now we use 2SampFTest and we find a computed test statistic which is 1.631 and a p-value of 0.4492 with more decimals. Now, using what we have learned before, we notice that the computed test statistic is in the non-critical region. Therefore, HO is valid. And since HO is valid, we assume that the two population standard deviations are equal, sigma 1 equal to sigma 2. Let's take a look at another example. A sample of 10 females, standard deviation of their ages was 5.2. A sample of 7 males, the standard deviation of ages was 2.5. Use alpha 0.1 significance level to determine if two population standard deviations are equal or not. So which one becomes sample 1? 10 females, standard deviation 5.2, 7 male, standard deviation of 2.5. So sample 1 will be females because they have a larger standard deviation. And sample 2 becomes the males, which has the smaller standard deviation. Our HO will be the two population standard deviations equal. And alternative hypothesis will be that the two population standard deviations are different. Again, using program fval as we discussed earlier and in other videos, that the right critical value becomes 4.099 and the left critical value is 0.296. Remember, when you're finding the left critical value, we have to switch the degrees of freedom, and then whatever the answer is, we take the reciprocal of that. The left critical value always will be smaller than 1. There is no negative critical values when working with F distribution. Now we use 2SampFTest and we find out that the computed test statistic F is 4.3264 and the p-value is 0.0885. Now, in this problem, the computed test statistic is in the right critical region, which means the null hypothesis HO is invalid, which is going to lead us to assume that the two population standard deviations are different. So sigma 1 is not equal to sigma 2. I hope this helped you understand and help us determine if the two population standard deviations are equal or not.